Okay, Unit 3, Assignment 9, pretest with test. So this first thing, if you've tried them all, hopefully you've tried them all, I was going to show you the answers. So you could pause it and check these answers. Check the ones across the top first. I'll move it up. There's answers on the bottom. So anyways, I'm going to go ahead and go over these problems. So first one, find the slope of a line, perpendicular line passing through these points. So probably want to find the slope of this line, rise or run, 5 minus 2 over 4 minus negative 1 equals 3 over 5. Slope perpendicular to it would be the negative reciprocal. So, negative 5/3. Next one, find the slope of line BC. Now, the way we could do this, a bunch of different ways we could do this. You might notice there's a 30, 60, 90 triangle. And that on its own probably isn't going to help. Now, you could do, you could draw a line straight down here, and it creates two new special right triangles. Here's a 30, 60, 90. Here's another 30, 60, 90. And I think that on its own could totally do the trick to help us find the slope of this, because slope is rise over run. This is 30, 60, 90. So you could say 1, 2, root 3, right? Special triangle. So the slope of BC is going to be down 1 over root 3. So the answer is negative root 3 over 3. That seems like the easiest way. I mean, there's other ways. You could say, you could find the slope of AC first, and you could use the trick I just showed you. This would be 1, 2, and root 3. So it'd be up root 3 over 1, and then the slope of BC is perpendicular to that, and it would be negative 1 over root 3, or negative root 3 over 3. So you could use the slope of AC. Now, another way to find the slope of AC, since it's rise over run, that's the same as tangent of 60 degrees. And you might be like, oh, okay, well, what's tan of 60? Well, it's sine of 60 over cosine of 60, probably, most likely. I'm not memorizing tangent values. Sine of 60 is 0, 1/2, root over 2, root 3 over 2. Sine of 60 is 1/2. And guess what you get? Now, that's the slope of AC, so then you could flip it. Or you could say the slope of BC is tangent of this. Well, actually, negative tangent of 30 degrees, because tangent is going to give you rise over run. We want to make sure it's negative. So, I mean, here's another way of doing it. So that'd be negative 1/2 over root 3 over 2. And give you negative 1 over root 3 and so forth. So anyways, I kind of like my first way because I thought that was pretty quick. Find an equation of a tangent line to this curve. Now this, we have x equals 3, so we need the y value at that point. So you need a point and a slope to write the equation of a line. This would be 9 plus 3 is 12. So the point is 3, 12. That's part of what you need. The other part you need is the slope. So we do y prime. So I am having you guys do a little calculus now, just as power rule, 2x plus 1. Then you're going to plug 3 in. We've been seeing this rule a lot, though, throughout several chapters. And so that's your slope. Now label your work, help me understand, follow what you're doing. So the equation is going to be y minus 12 equals 7 times x minus 3. Point slope form, stop. Don't do anything else. Don't change it to slope intercept. If you do, you can get full credit still, but if you make a mistake, I'm taking off points that you already had 100% of. Don't do extra work. Also, you don't have time. Okay? This test is going to be tough to get done in the amount of time, so you got to you got to realize, well, if I don't need to do this, don't do it. Find the maximal and minimal values of this function. So this is extreme value theorem. You have your endpoints, right? We need critical points. So that's going to be y prime equals 2x minus 6 equals 0. So 2x equals 6, so x equals 3 is your critical point, okay? Then we're going to make a table, plug them into the original function. We're trying to find the max min of the original function. So 0, 3, and 10. If you plug 0 in here, you get 0. You plug 3 in, you get 9. Minus 18 is negative 9. Plug 10 in, you get 100. Minus 60 is 40. So here's your max. Here's your min. I've been asking you to write your answers in a very specific way. I would say the maximum or maximal value of y is 40 at x equals 10. The minimal or minimum value of y is negative 9 at x equals 3 by extreme value theorem. Gotta name it by checking endpoints and critical points. So I don't care if my solution's online, don't have this, I need it. I'm telling you right now by checking endpoints and critical points. So this is what I'm looking for. This is what you would have to do on a free response question to get full credit on the AP exam. So you might as well start practicing now. Okay, so that's the work. That's the answer, explanation. Number 5, this is a rock problem. So we derived the equations. I mean, we could derive them again. The acceleration is negative 32 feet per second due to gravity. So the velocity is the acceleration. And we're kind of going backwards here. So negative 32t plus the initial velocity. And then the position, and you could just memorize this if you want, negative 16t squared, because we're going to bump it up 1. And then, but we want to make sure that when you take the derivative of this, it gives you that. Plus v naught t plus s naught. So you can just memorize those if you want. It's involving the work that we have been doing. So for us, the rock is thrown upwards. So this is your V naught at a height of this. This is your S naught above sea level. So our equation is negative 16t squared plus 32t plus 128. So you could just memorize this and just start with that. And then it's really easy from here to get velocity if you want, because you just take the derivative. That's a lot easier than doing derivatives backwards, and the acceleration due to gravity should always come out to negative 32 feet per second squared. So the units are feet and seconds for time. So trying to find the max height. Well, the max height is the max S, right? So that's an absolute max. We need to do extreme value theorem. So we got to find the endpoints. Now, one endpoint is time 0. Usually on time problems, time equals 0 is the beginning of time. We're not going to go negative time. We need the other endpoint when it stops. Well, that's when it hits the ground. So that's impact. And the time that happens is when the height is 0. So we set the height equal to 0. And we figure out when that happens. So it's going to be, I think we try and factor out the GCF, negative 16. That's 8. And then hopefully you can factor this. Otherwise, we're going to use quadratic formula. It's going to be, I think it's going to be minus 4 plus 2. So t equals 4 and t equals negative 2. Now, you usually get 2 times the impact, but we're not going to go back in time. Okay, that'd act like the rock was actually already being thrown before it was thrown. So that's your other endpoint. So endpoints for time are going to be 0 and 4. Okay. Now, critical points are when the thing you're trying to maximize or minimize equals 0. So we're going to take a derivative of that, which also happens to be the velocity, which also makes sense that when you get to the top of the path of something thrown up, and right before it turns around, velocity is 0 for a second. So we're going to set the derivative of the thing we're trying to maximize, which happens to also be velocity, equals 0, and time equals 1. That's your critical point. In terms of motion, we call it like a turning point. Then we're going to make a table of values, just like we do anytime we're looking for, we're plugging time into position. Now, the endpoints are 0 and 4, and the critical point's 1. Now, 0 should be easy. You plug 0 in, you should get 128, because that's the initial height. You plug 4 in, you should get 0, because that's how we found time to impact. So ours one is 1, so negative 16 plus 32 plus 128 equals, that's 160, 144. So that is your max. And so now we're going to write the answer. The maximum height of the rock is 144 feet. I need units at time t equals 1 second. Need units by extreme value theorem by checking endpoints and critical points. So that's a good thorough answer. That's what I'm looking for. Okay. Part B says the velocity impact. Now I'm kind of running out of room, so I'm going to just put it right here. So the velocity of impact would be plug time of impact 1 into your velocity equation. And at time 4 is your velocity impact. Negative 32 times 4 plus 32. It's going to be negative 96 feet per second. That's the velocity impact. Okay. All right. Number 6, optimization. If any has $800 spent on a fence, there's goats. The heavily shaded costs $5. The dash size costs $4. Find X and Y when the enclosed area is maximized. So the X and Y are given to you on the picture, so we can go ahead and use those in our answers. We don't have to say parallel sides or whatever. Now, I would put, if this is X, then this is X, and this is X, and then if this is 50 and this is 30, then this is 20. And so then this would be X minus 20. And we just need fencing. We don't need fencing where the building is. So then I put the prices down. Heavily shaded is $5. So this is $5 a foot. This is $5 a foot. This is $5 a foot. And then the other ones, the dash ones, are $4 a foot. So this is $4 a foot. And this is $4 a foot. So it's good to really label your picture. Find X, Y, and close the areas and maximize. Okay, and we have $800 to spend. So we need an equation for the thing we're trying to maximize. And that would be the area, which is really simply a rectangle X times Y. Great, easy. But we want it in terms of one variable. So that's where the cost comes in. So since the cost is $800, we need to add up all the fencing. So we have 5x plus 4x plus 4x plus 5y plus 5 times x minus 20 in parentheses. It has to be distributed. Okay. So 800 equals, we have 13 18x's, 5y's minus 100. So need to solve for x or y. It's up to you. I think both of them are going to give us fractions, so I'm going to go ahead and solve for y. So I'm going to subtract 18x from both sides. I'm going to add 100 to both sides. And so then I'm going to get 5y equals 900 minus 18x. So then I'm going to divide by 5. And y equals 5 goes in 120 times, so that would be 180, 9/20s, minus 18 fifths x. Okay, and we're going to plug that back in up here to get our equation in purely terms of x or y. So this is going to be x times 180 minus 18 fifths x, which is also 180x minus 18 fifths x squared. Now I'm going to use this in my table. I'm going to use this for my derivative. So we now have an equation in terms of one variable. No calculus, lots of geometry and algebra. So calculus is, okay, let's check the endpoints and critical points. So the critical points are going to be the derivative. I'm going to do derivative of this. And then we set it equal to 0, because it's when it's flat. And then we solve. So we multiply by 5 over 36. And I think that's actually, what, 5 times. So it's 25. It's kind of a nice answer. That's your critical point. Now, the endpoints for x, because we got everything in terms of x, if we got everything in terms of y, then we need to find endpoints for y. Now, what's the smallest x can be? Definitely can't be negative. Can't have negative fences. Can it be 0? Nope, because then you get a negative fence here. The smallest x could be is 20. What's the biggest x could be? Well, that's going to be when y is the smallest, because the less you use for y, the more you have for x. Y could be 0. We can move all these fences and build them all right next to each other. It seems weird, but you can do it. Can't have negative fences, though. Negative fences actually make you money and stuff. That's weird. So we take our equation right here for y, and we set it equal to 0 and figure out what the x would be that would go with this. And it would be 50. So those are our endpoints. So now we're going to make a table. Kind of running out of room here. Plug x in to the area, which I'm going to use the factored version because I think that makes it easier to do it in my head. And it has the y built into it. So we're going to plug in 20, 25, and 50. So you plug 20 in, it's going to be 20 times 20 years, it's going to be 4 times that is 72. So that's going to be 108. So that's going to be 216 with the 0 on the end of it. And then 25, it's going to be 5 times that, which is going to be 90. So that's going to be 90. Now, every 4, I don't know how we're going to do this. 9 25s would be 225, and then add a 0 on the end of it. And then 50 would actually be 50 times 0, which is 0. So there's your max. There's your min. So now we're going to write the answer nicely. We're going to say the area is maximized at 2250 square feet, right? When x equals 25 feet and y equals, now that's the y value right there. That's why another reason I like that. 90 feet by extreme value theorem. Checking endpoints and critical points. Now, on your test, if you're like, man, these are so hard and I don't know what to do. Okay, well, skip it. Come back to it later. There's tons of problems on here that you can get points on. This is one. And I think for a lot of people that might be their harder one. So, okay, let's see. So next problem, we have functions, function operations. So g of 8 would be the square root of 4, which is 2, minus f of negative 1 would be positive 1, minus 2 is negative 1. I'm just careful here. I'm putting parentheses, so it's going to be 4 plus 1, which is 5. Okay, this one, we're going to plug a plus 2 in for every x we see. Okay, minus, now I'm putting extra parentheses and stuff, minus 2a being plugged in. But then you gotta distribute this subtraction. So let's try and simplify this. It says a squared plus 4a plus 4 plus 2a plus 4 minus 4a squared. The 2 gets squared also, minus 4a. Okay, now let's combine like terms. There's a squared and minus 4a squared, so it's negative 3a squared. And you can kind of cross things off to make sure you didn't forget one. You have 4a and a minus 4a cancels each other out, so you have a 2a left. Then you have 4 plus a 4 is an 8. So that's your answer. Just be careful on this, right? Just show your work. Be extra careful, especially with parentheses and distributing negatives. That's going to be a bad mistake on that. You guys have been not distributing subtraction since algebra 1, and it's not cool anymore. Domain of this, well, the inside has to be greater than or equal to 0. So x has to be greater than or equal to 4. The domain is 4 to positive infinity. I want an interval notation. Okay? And of course, you can write your answers in the answer column, but I'm just skipping that for right now so I can get this video done quicker. The domain of hx is the inside of a natural log has to be positive, cannot equal 0. So x equals 3 halves is an x-intercept of x equals negative 1 is a vertical asymptote. You can do a line check. So you can open dot negative 1, open dot at 3 halves, which is 1.5. Test a value like x equals 2. It's all positive, true, false, true. So your answer is negative infinity to negative 1 union 3 halves or 1.5 or 1.5 to positive infinity. So doing a lot of domain stuff this unit. This one, this is being plugged in there, so we got to do, well, what's g of 8? G of 8 would be square root of 4 is 2, right? Then we could say, well, f of 2 would be 4 plus 4 is 8, and then h of 4 would be natural log of 8 minus 3 is 5 over 5, which is natural log of 1. Now, if you leave your answer like this and taking off points, natural log of 1 is 0. Log with any base of 1. What do you raise e to get 1? 0. So final answer is 8. If you leave the natural log 1 in there, you're not going to get full credit. Okay, number 12. Find m and b so f of x is continuous and differentiable. So we're not trying to decide if it's continuous or differentiable. You want to make it continuous and differentiable. So there's two issues. Continuity is that, continuous is that the y values at the transition are equal to each other. So plug 3 into them. 27 minus 3 is 24, right? And then you plug 3 into this, and it gives you 3m plus b, and these have to be equal to each other. So there's one of your equations. 24 equals 3m plus b. Okay, they're looking for two things, so we need two different conditions to get two different equations so we can solve the system of equations. So differentiable means that the derivative exists, which means that the derivatives at the transition point have to be equal. So we got to first find the derivatives of each piece. 3x squared minus 1 for x is less than 3. And this one is just going to be m. That's a line, right? Y equals mx plus b. M is the slope of the line. Now, I can't put the or equals here yet. Well, I guess I can because we're going to make this true. So those have to be equal. So, well, we got to plug 3 in and then make them equal to each other. So plug 3 in. You get 27 minus 1 is 26. And plug 3 in m is just m, and these have to be equal. So m equals 26 is actually one of your answers. So this is an easier system of equations because now we don't have to eliminate anything. It just happened on its own. We plug that into there. $60, $78. So b equals 54, negative 54. So there you go. Okay, so probably a problem like that. Number 13, sketch a piecewise function. So we've been doing a lot of these. We've been sketching a lot of functions. So we do parabola. Now this graph, you probably want to try and make decent because you kind of want to know if these pieces actually do connect. So I'm gonna put a little more effort into trying to make sure that this graph is pretty good since we're dealing with multiple functions together. So I'm trying to make these look pretty good. So the parabola is 0, 0, 1, 1, 2, 4, negative 2, 4. So lightly graphing that. Okay, and the other one's a line, negative 2, up 3 over 1. Hey, that connects up 3 over, oh, it connects even there too. Up 3 over 1. This is, or down 1, 2, 3, backwards 1. So this should be a straight line. And it actually hits some really nice points on your parabola. And the other one is a horizontal line, y equals 1. Okay, now, from 0 to 2, it's the parabola. So I'm going to darken in the parabola from 0 to 2. Okay. From 2 to 4, it's the line. So up 3 over 2 over 1. So it's this right here. Now, those are open dots actually. Open dot there, open dot at 2, open dot here, because these don't have the or equals to. And then everywhere else it's 1, which means solid dot here and everything to the left that we didn't define yet is going to be equal 1, arrow. And then at 4, it starts as solid dot because there was an open dot at 4 before, an arrow to the right. And then here's the tricky one. There is a solid dot at 2 because no one had defined what x equals 2 was yet. So that is your graph. Okay. Number 14, determine a piecewise formula for f of x. So we're going to try and come up with the piecewise formula for it. So we're going to try and do f of x equals curly brace. Now there's the equation of this is y equals 1. That one's kind of easy. This one is up 1 over 2. So the equation of this is going to be y equals up 1 over 2x, and the y-intercept is 0. So this one's kind of easy. So we're going to say that f of x equals, and usually you kind of go left to right. So the first chunk is going to be 1/2 x. Don't put the y equals in here, okay? And that's for x is less than 2. and then y equals 1 for when x is greater than 2. Now, it's up to you which one you want to assign 2 to. You could put it here and not here, or you could put it here and not there. You should not put it on both. You need to have it on one. So it's either that, or you could do the same thing and say x is less than 2, and then say x is greater than or equal to 2. That would be okay. One of those options. If you put it on both, I'm taking off points. All right. So, anyways, there you go. Write the equation. Now, these ones, this is going to be worth a ton of points on your test. And it's actually doesn't take very long, but it is kind of easy to mess up. I think your best option on 15, this is going to be worth a ton of points. So you want to do well in these is to sketch these, because telling if it's increasing, decreasing, concave up or down, asymptotes, that's what I had you guys do in the homework after you sketched them. And those are easy questions to answer if you have the correct sketch. I don't know without a sketch, I think you wouldn't do that well. So I don't really have much room here, but I'm gonna try and sneak these sketches in. And small, they don't need to be great. They're just, so the first one is y equals 2 to the x, that's the parent function. And then it gets shifted down 3. So 1, 2, 3, y equals -3. Intercept is at now 0, -2. And this is your graph. Now, if you do that, you should easily say it is increasing and that it's concave up, and then its asymptote is y equals -3. Now, in the asymptotes, you could write the equation line, either y equals or x equals. Okay, horizontal asymptote is y equals. Okay, that sketch was huge. That sketch, I don't know. Now, natural log, you might do y equals e to the x first, and then flip it across y equals x, because that's their relationship. And then you get a vertical asymptote at x equals 0. And then the 4 is going to move everything up 4. 1, 2, 3, 4. Now, the graph still has the same vertical asymptote. Up 4, yeah. Okay, so it is increasing. It's going up from left to right. It's concave down. And the asymptote is x equals 0. Bunch of points. Sketch makes it easy. Next one is 10 to the x. Looks like that. Right? And then the -1 on the inside moves everything to the right one. So now your intercept, that what used to be your y-intercept now is at 1, 1. And then the 2 moves everything up 2. So including the asymptote. So the final graph looks like this, which is definitely increasing. It is concave up. The asymptote is y equals 2. Okay, let's do another one. Y equals e to the x. The negative on the inside flips it across. The negative on the outside flips it upside down. And then the +1 moves everything up 1. So your final graph looks like this. Okay, it is increasing. It is concave down, and its asymptote is y equals 1. Okay. For more log of 1/2, I would do y equals 1/2 to the x, which I would actually interpret as 2 to the negative x. So I would do y equals 2 to the x. The negative on the inside flips it across here. And I'm going to flip all this across y equals x. This is 0, 1. This is y equals 0. So now it's going to be x equals 0. And it's going to be 1, 0. So, and it's that flipped one. So it's going to look like that. And then the -3 on the inside moves everything to the left, right 3. 1, 2, 3. So the asymptote's at x equals 3. The intercept's at 4, 0. And the graph looks like this. So it is decreasing and is concave up, and its asymptote is x equals 3. Okay, one more. There's a lot of points, so take your time. And so y equals 1/3 to the x is the parent function, but I'm going to think of it as y equals 3 to the negative x. So I'm going to do y equals 3 to the x, and then flip it across because it's negative. And then the minus 2 on the inside moves everything to the right 2. So it looks like that. And then the plus 1 on the outside moves it up 1. So this was 2, 1. This is now 2, 2. And it moves everything up 1, including the asymptote. So y equals 1. So your final graph looks like that. So that is decreasing, concave up, y equals 1. So bunch of points on those. Sketches, I think, are the way to go. Exponential growth. Now, exponential growth is y equals y naught e to the kt. So you could just memorize that. Investments growing exponentially triples in value in 50 years. So it's tripling time. Find the exact value of its growth rate. That's the k value. So if it triples, then you have 3 times your initial amount. So we don't even know what the initial amount or the amount in 50 years is, but we know it triples. So we'll say the initial amount is y sub 0, and the tripled amount is 3 times y sub 0, e to the k, and we have the time as 50. Now, if you divide both sides by y naught, that goes away. Then you're going to take the natural log of both sides to get rid of the e, or bring this in front, and then natural log e is 1. So then k equals natural log of 3 over 50. There you go. Don't have a calculator, so. Okay, 17 to 20, some more sketching practice. So x to the 2/3 is the 0, 0, 1, 1. That's the Siegel function. I don't know if you guys remember that. 8 would be 2, would be 4. So it kind of looks like this. This is the parent function, okay? Then the minus 2 inside moves it to the right 2. So that's what we have now. And then the negative flips it upside down. Okay. And then the plus 1 moves everything up 1. So your final graph is like that. I think I want that kind of cusp labeled. That's at 1, 1 now. It was at 0, 0 originally. Then it became 2, 0. Oh, this is going to be 2, 1. Then it became 2, 0. And then got flipped. It still was 2, 0. And it got moved up 1. So it's 2, 1. So, all right. Natural log graph. I like to graph e to the x first. And then flip it across y equals x. Okay, so that's natural log. The minus 2 moves everything to the right 2. So we're at 3, 0 now. And the horizontal asymptote is now at x equals 2. So it looks like this. The absolute value flips this part up, and then the negative flips it all upside down. Arrows, asymptotes labeled, intercept labeled. Okay, next one is 10 to the x. Now, 10 to the x would look like this. Now, there's an absolute value. You got to work from the inside out. The absolute value on the inside, what it does is it treats the negatives like positives. So it's like it flips it. But we keep this side and then replace this side with this. And then the negative flips it upside down. So the graph looks like, it might be easier to draw the two upside down exponentials and then do it like this. Now that should have, there's like a point right there at 0, 1. It's a bit of a sharp point. Should look like a smooth curve. All right, this one, e to the x, the minus 2 on the inside moves everything to the right 2. The negative on the outside flips it upside down. The plus 3 moves everything up 3. 1, 2, 3. So, including the asymptote. So we're at y equals 3, and then the graph looks like this. Okay, so there you go. And that point is the point I want you to keep track of. And the asymptote should be labeled. And I should see the work leading up to it. Okay, domain questions. Domain, x cannot be -3. That's the only issue there. So that means that it's everything other than -3. So it's -infinity, -3, and then -3 to positive infinity. Parentheses, I need these in interval notation. Okay, this one, the inside has to be positive or 0. So then you're going to factor it. And you get a polynomial inequality. So you're going to do a line check like we did back in chapter 1. These are going to be solid dots. I'm going to test a value. Tell me what you test. X equals 7. True, false, true. And so it's going to be -infinity to 0, bracket, and then 6 to positive infinity. Okay. Next one, natural logs. The inside has to be positive, cannot be 0. So we're going to factor it. X equals 0, x equals 6. You're going to do a line check. These are open dots. Test a value. Tell me what you test. I'm going to do 7, which is positive, positive, true, false, true. So the final answer is -infinity to 0, parentheses, union 6 to positive infinity. All right. So you have some domain questions, and domain's also going to sneak into some problems. Symmetry, even, odd, or neither. So the way you do this is the work I need is you can plug a and negative a in. So you're going to plug these into y. So this is going to be a to the 4th minus a squared over a. So then this is going to be negative a to the 4th minus negative a squared over negative a. And I want to see this work. Now let's simplify this. That's going to be positive a to the 4th minus a squared over negative a. Now that's the same thing as negative a to the 4th minus a squared all over a, which makes these the opposite, and therefore it is an odd, has odd symmetry. That's the kind of work I'm looking for. Okay, so x, a, negative a, plug into y, sine a over a cubed plus a, sine negative a over negative a cubed plus negative a. Trig identity, sine and negative a is the same thing as negative sine a, and this is going to be negative a cubed, and that's going to be minus a. Now what you should realize is that you could factor a negative out of everything on the top and negative out of everything on the bottom, and the negatives will go away. So you get sine a over a cubed plus a, which is the same. When they're the same, it's even. So next one, x, a, negative a, plug in y. This is going to be a squared plus absolute value of a over cosine a. You cannot get rid of those absolute values because what if a is negative? But it's, no, we don't know the value of a. Now plug negative a in. And we'll use, it's going to be positive a squared plus the absolute value of a. Now the absolute value of negative a is the same as the absolute value of positive a. The trig identity for cosine negative a is it's the same. And so these end up all coming out the same, right? And so it is an even function. Okay, last one, x, y, a, negative a squared plus 1 over sine a negative a parentheses squared plus negative a parentheses plus 1 over sine negative a equals positive a squared minus a plus 1 over negative sine a. Now this looks really close to being the opposite, but it is not. Okay? I mean, it's negative a squared minus a plus 1 over sine a. It's close, but this right here is the problem. So it is neither. Okay, that's the kind of work I need to see to get credit for those. Okay, now, yeah. Last page, got a couple inverses here. So you got to be able to find the inverse function. So what I would do is I'd change it to y if it's not, because that's easier than dragging f's around. Okay, and then I'd swap the x and the y with each other, and then I'd solve for the new y. So squared add 2 y equals x squared plus 2. So this is the inverse function. Now I'm going to go ahead and name it directly because they started with that kind of notation. So I'm going to write my answer in a way that kind of matches the way the problem was given to me. Okay? I mean, this is okay also. This is just a little better. Okay, y. Swap the x's and y's. And then you got to solve. I'm going to cross multiply xy minus x equals 2y plus 5. I'm going to subtract the 2y over here. I'm going to add the x over here. So I can get all my y terms together. And then I'm going to factor y out of them because I can't combine them together. And I can divide both sides by that. So the inverse function is y equals x plus 5 over x minus 2. Or, maybe a little better, the inverse function equals x plus 5 over x minus 2. Because there was really no y's in the work, but either of those is fine. So you guys should be able to do those. You guys should be able to sketch conic sections. So squared, this is the work I would do. 9 minus x squared, the negative gets squared, move the x squared over here, and this is clearly a circle. So we're going to go up 3, 1, 2, 3, down 3, right 3, left 3, and I'm going to just draw it lightly first. Is it the whole thing? Just the bottom. Watch out for that. Okay, just the bottom. Okay, this one, squared, y squared equals 4 times 1 minus x squared. Y squared equals 4 minus 4x squared. 4x squared plus 4, y squared equals 4. This is an ellipse, so we need to make that into a 1 on the right side. So that's x squared over 1 plus y squared over 4 equals 1. This is an ellipse. Okay, you're going to go up 1, down 1, right 2, left 2. Whatever's underneath the y's, that's the direction you go. That's how far you go on the y's. Whatever's underneath the x's, that's what you go. Now we usually draw a little box here. This is pretty small. And then sketch it inside. Is it the whole ellipse? Nope, just the bottom. So, you know what? I messed up. I'm supposed to go down -2, up +2, and right 1, left 1. So it really should be like this. And it's the bottom. So it should be like this. I messed up. I swapped the values. So, okay, this one, squared, y squared equals 36 plus 4x squared. Subtract this over here. this is a hyperbola. So we need to get it into, so it's 1 y² over 36 minus x² over 9 equals 1. This is a hyperbola. And it's just the bottom half. So we're going to go up 6. 1, 2, 3, 4, 5, 6. Down 6. 1, 2, 3, 4, 5, 6. Right 3. 1, 2, 3. Left 3. 1, 2, 3. Draw a box. Draw the slant asymptotes, diagonals through the corners of the box. This is going to be an up-down graph because the y-squareds are positive, but we're only doing the bottom half. Should look like it's going towards the asymptotes, not crossing them, not going back away from them. Darken it in, put arrows on the ends, I want arrows. So there you go. Okay, number 33, find the slope of the tangent line to this. This is that one where that's a circle. So the radius is the square root of 20. So I'm going to do a quick sketch of a circle. This is the one, this is the way that's faster than doing calculus. So it's a circle. And we're looking at point 2, -4. So square root of 20, by the way, is about 4.5 probably. So 2 would probably be around here. 4 would be around, right around there. 2, -4. This is the tangent line. We want the slope, just the slope of it. So we want this, we got to find the slope of the radius. The slope of the radius is down 4 over 2. It's -2, down 4 over 2. So the slope of the tangent line is perpendicular to that. It's going to be positive 1/2. There you go. And then we have function table problem. So f of 2 is 0. G of 0 is 0. Got to work from the inside out. So g of 3 is 1. F of 1 is 1. K of 1 is 0. Okay, now we're going to solve. And you say, well, what would I plug in to K to get 1? So you work backwards. You plug 0 in. So that means that hx has to equal 0. So then you say, well, what would I plug in h to get 0? 2. And x equals should be part of your answer. And zeros are x-intercepts. So same kind of idea, but we have to kind of work from the outside in. So we got to say, well, what would K of what would be 0? And you say, well, that'd be a 1. So then you say, well, F of what would be 1? Well, that would be a 1. And you say, okay, well, K of what would be 1? K of 1 would be 0. X equals 0. So there you go. That's pretest. The actual test will have all these kinds of problems on it. Maybe a little less of some of them that had repeated value, repeated problems. Probably a little less, but this is all stuff you need to be ready for. Okay.